Hello and welcome to my videos. My name is Ashish and we are learning Rust programming. And in today's video, we are going to continue with how to implement threads in Rust programming. So in last video, we have seen how to implement thread in Rust using thread spawn method from standard library. And in this video, we are going to see how to pass message between the threads. So one increasingly popular approach to ensuring safe concurrency is message passing, where threads or actors communicate by sending each other messages containing data. And this is a very common scenario. To accomplish message sending concurrency, Rust standard library provides an implementation of channels. Channel is a general programming concept by which data is sent from one thread to another. So you can imagine a channel in programming as being like a directional channel of water, such as stream of a river. You put something like a rubber duck into a river, it will travel downstream to end of the waterway. So if you know the traditional producer-consumer problem, so you can think of there is one channel shared between consumer and producer, and producer produces the data and sends that data to a consumer. Something similar happens when we use message passing in Rust. So channel has two halves. One is transmitter and a receiver. Like I mentioned, producer and consumer. The transmitter half is the upstream location where you put the rubber duck into the river, and receiver half is where the rubber duck ends up downstream. One part of your code calls methods on a transmitter with data you want to send, and another part checks the receiving end for the arriving message. So let's look at examples. So for that, we have to use package standard sync MPSC. MPSC is the name, and we initiate to TX and RX MPSC channel. So this is how we instantiate our channel. Now for this channel, we need a transmitter and one receiver. So let's create one transmitter. We have one thread spawn. We have one method here. Let val equal to string. So this is going to be our message. String from hello. So this is going to be our message, and we are going to pass this message. Okay, fine. Now this is about sending the message. Now we need somebody at the receiving end. But before that, let's look at this move keyword. So we are using thread spawn, and to create a new thread, then using move to move tx into a closure. So we are moving this tx into the closure. That's why we are using this move keyword. So that spawn thread owns this tx. So we'll talk about this ownership shortly, how to transfer this ownership. But let's move ahead and implement receiver. So in this case, we can use main method, main thread as the receiver. From Rx, we can receive the data, use unwrap, and here I can print that. I can try to print that data, and data is received. All right. So let's run this program. So output is received. Whatever we sent from one thread, we have received in our receiver, that is main thread. We passed value from this background thread, and we received that value in the main thread. So channel and ownership. Let's talk about channels and ownership transference. The ownership rules play a vital role in message sending because they help you to write safe and concurrent code. Please remember, or please recall, when we started with threading, we mentioned fearless concurrency, and it's because of clear-cut rules defined for ownership. So to prevent error in concurrent programming, it's an advantage of thinking about ownership throughout. Whenever you are writing, at the time of the developer has to think about the ownership of any data structure that is going to be shared. So yeah, so let's go ahead. So if I add here println, and if I try to print value here, so I'm trying to access the value after that value being sent. Okay, so here what you can see is borrow of moved value value borrowed here after move. So what it is saying, that it is not letting me to use, allowing me to use this use of value, because we try to print val after we have sent it down the channel via tx send. Allowing these would be a bad idea, because once the value has been sent to another thread, that thread could modify or drop it before we can use that value again. potentially the other threads modification could cause errors or unexpected results due to inconsistent or non-existent data. So maybe that value has gone, and this sending thread, we are using this value. So that's why Rust gives us an error if we try to compile the code. So spawn thread needs to own the transmitter to be able to send message through the channel. So that's the reason we use this move keyword. And after that, this value that we have created inside the spawn, since we have used tx.send, the ownership has again changed back to the receiver side. We are not able to use that value again. So our concurrency mistake has caused the compile time error. The send function takes the ownership of its parameter when the value is moved, and receiver becomes the owner of that variable. So in this case, this receiver, that is main method, main thread, becomes the owner of this value. So that's why it is not letting me use this. Now let's look at how to send multiple values from one thread to another. So if I have, let's say, vector, instead of this, what I can do is I can have vector of strings. Let me define two more strings. So I have B, C, D. And then what I'm doing is, so here I'm receiving this vector, and what I need to do is I can, yeah, so you can see, so it has sent the values, and I can other way around is I can send values through I can run the for loop and send the values. So this is how I can send multiple values. So yeah, so this is how we can share message between threads in Rust. That's it from this video. If you like, if you are liking the content, then please like, share, subscribe my channel. Thanks for watching.